Hey guys, in this video we'll see how to create server-side app using Datfrog. On the left hand side we have the server-side app created using Datfrog, and in the center we have a client created using Flutter. We upload an image from your local machine to the server, and in the server side we recognize if the uploaded image is of a celebrity. So this is done using a service called as Rekognition provided by AWS. Let's click on pick file and we select a file from our local machine. This file is uploaded to the server, and yes, it matches the face of Warren Buffett and the percentage of matching is 99. And if we upload a file which is not of a celebrity and we click choose, server responds with no celebrity found. Datfrog is a fast, minimalistic backend framework for Dart. It's built on top of Shell and Mason, inspired by tools like NextJS, ExpressJS, and this is actively developed by Very Good Venture. The endpoints created using Datfrog can either be deployed on Google Cloud Run, AWS, or DigitalOcean. There are some prerequisites for using Datfrog. First is we need to have a Dart version from 2.17 and above. Let's install the Datfrog CLI. We copy this command, paste it, and run this. It installs the Datfrog CLI. So we run the Datfrog command and we see that it's installed in our machine, and these are the available commands: build, create, dev, and update. Let's create our Datfrog app using Datfrog create and name of your project. It creates a Datfrog app, installs some dependencies, and gives us a bare bones app. This is how the app looks like. In the pubspec YAML, it has dependency, mocktail, test, very good analysis, and in the dependencies, it has Datfrog. In the route folder, it has one file called as index.dat, gives us a simple response welcome.datfrog. One thing to note is since this index.dat is directly placed in the routes, so once this server loads up, this would be the first response which would be loaded. We also have a test which basically checks whether the response gives us welcome to Datfrog. Let's run the server using the command datfrog dev, and what this does is it creates a server running on localhost port 8080. Let's click on this link now. So it should give us welcome to Datfrog. If we try to change the response in our body, welcome to ssfrog, this reload, and if we reload our server, welcome to ssfrog. Since Datfrog is based on top of Shell, so if we go into this Datfrog folder in the server.file, we could see that it internally creates a server, registers a handler, and then all the routes related to this project. So Datfrog has this hot reload functionality, and this hot reload comes from the package shell hot reload. We will be integrating a service called as AWS Rekognition, which is used for deep learning based visual analysis. We will use the celebrity recognition from this AWS Rekognition service. This service takes in the parameter as an image. It detects whether the image uploaded is of a celebrity, and then it gives us back the response in the form of celebrity faces, the URL, name, ID, and a matching score. Install the AWS Rekognition API available for Dart as well as Flutter. We create a folder called as server. Inside this folder we have two packages. The first one is Rekognition, the other one is Rekognition data source. We have the file Rekognition data source base, which is basically an abstract class and takes in two functions: recognize celebrity and recognize if celebrity. The second function takes in a parameter of image bytes. We export the abstract class using library in the form of Rekognition data source. Let's look at the second package, Rekognition, which comprises of dependency Rekognition data source as well as AWS Rekognition API. We create a file Rekognition base, inside which we implement the abstract class which we saw in the previous package. The first thing we do is create a Rekognition object, and this comes from the package AWS API. We pass this object three parameters. The first is region, the second is the access key, and the third is the secret key in the form of AWS client credentials. The access and secret keys can be obtained from your AWS account. We implement the first function recognize celebrity. So inside this we call the service.recognize celebrity, and this function is coming from the package AWS Rekognition API. The method recognize celebrity requires a parameter image, and this image can be of type S3 bucket or it can be a byte. In this function we pass the image in form of an S3 object, and inside this S3 object we need to specify bucket, the name of the file. Note bucket here and the file here should be public and be present in your AWS account. This is our AWS account and this is the S3 bucket. We have the file here. The response back from the service is in the form of a recognized celebrities response. We create a celebrity model using equitable and JSON serializable. This model comprises of name, URL, matching confidence, and the ID. This is how the recognized celebrities response class looks like. It comprises of celebrity faces in form of a list of celebrity, orientation correction, and list of compared faces. If we head over to the celebrity class, we see it comprises of a compared face, ID, which is a unique identifier of the celebrity, match confidence, the percentage that recognized, and the name of the celebrity. We decode the response and finally send over as a map of string and a list of celebrity model. In the other function, we pass in the parameter of image bytes. We call the service.recognize celebrities and instead we pass the image in the form of byte. We do the same checks as above function and finally return back the response. We use all the files which we created and export them inside our library Rekognition. Doing this, we make sure first our AWS library is present only inside this package Rekognition, and secondly, this approach is easily testable. There are times when we need to copy-paste a snippet and share with our teams. Introducing Pieces, a code snippet manager we have been waiting for. It's beautifully integrated in your work environment, for instance, VS Code, JetBrains, or even Google Chrome. They have a desktop app for Windows, Apple, and Linux users. Let's install the Pieces desktop app for macOS, which is entirely free. We can see all our previous saved snippets by just scrolling down here. If you want to share a snippet with your team, you just click on this button, which generates a shareable link. You can get all the relevant information from a snippet using this quick menu. So you can see here there is a shareable link for the snippet, a description, and also related links related to this snippet. And there is a handy button which says all the activities which you did in this app. Let's say you are searching solution of a problem and you encounter a useful snippet. So let's say you want to save this. So you simply click on copy and save. It gets automatically saved inside your Pieces app. And if we navigate here, we see the snippet which we just got saved. These options are available since we have installed the Pieces as a Chrome extension, and this extension extracts all the snippets related to this Stack Overflow link. We can also save a snippet from VS Code by just highlighting the snippet we want to save. Right click and choose Save to Pieces. On the bottom right, we see the snippet has been saved to Pieces. Heading back to the app, we see the snippet was saved, and this was possible using the Pieces plugin for VS Code. So next time, instead of bookmarking, try Pieces. There are times when we need to store the keys in our code. See how we can do that in a secure way. We make use of this package called as nveed, which is a cleaner way to handle your environment variable in Dart as well as Flutter. For using this package in a Dart project, we first add the package nveed and a dev dependency nveed generator as well as build runner. We add them inside our project under dev dependency as well as dependency. Next, we create a .env file and we specify the three type of keys: access key, secret key, and region key. We create a file called as env.dart, and all the variable names inside this file should match with the one which you created in the .env. So as you can see from the left hand side, the var name, access key, secret key, and region key match with the ones on the right hand side. In this file, we also imported the package nv, and in the starting, as you can see here, we mention the path as .env since our file name is .env, and we make sure the authenticate is set to true. Finally, we run the command which helps us in generating the file env.g.dart. Note that this package recommends your both files env as well as env.g files should be added to the git ignore, and we do the same. Now we need to add the route which can be exposed by our server to end users. We create a folder API/v1, and inside this we have two subfolders, recognize if celebrity and recognize test. Both these folders contain the file index.dart, so this means both of these will serve as two different endpoints. We open the index.dart, so inside this we see the onRequest function. So this is the first function which gets invoked when this endpoint is hit. We compare if the method is get, so we proceed. Otherwise, all these methods like post, put, etc. as method not allowed. Inside the get method, we pass in the request context. Using the context, we read the image recognition repository, and finally we call in the function recognize celebrity. And if you recall, this is the abstract class which we have included in our package. The response is sent back from the server to the client in the form of response response.json. Looking at the other endpoint, recognize if celebrity, we do the same thing. We filter out all the methods except the post. In the post method, we first pass in the context and we get access to the image recognition repo. Next, we extract the request form data and store it in a variable. We get access to the property image which is found in the request data. Next, we use the base64 decode function which comes out from the package .convert, and we pass in the bytes parameter which is in form of a string. Next, we call in the function recognize if celebrity which takes in the parameter uint8list. The response, which is in the form of again a map of string and list of celebrity model, is passed as a JSON to the client. We also have a file called as middleware.dart. So what this does is it allows us to execute code before and after a request is processed, and we can modify the inbound requests and responses accordingly. So in our case, what we do is we add a request logger which is coming from the Dart framework itself. So basically it logs in the time of the request, and also we add in the image recognition repo and its implementation as a data source. By using provider, which is it provides a value to the current handler by creating it lazily, and also this provider can also be thought as a type of middleware which is helping for dependency injection. Let's now test our endpoints, and we do so by calling the Dart dev which starts as local server on the port 8080. And if we try to curl the endpoint using the function here, so we get the response back as data in the form of ID, match confidence, name, and URLs. We create a Flutter client desktop app. We include the packages Rekognition, which comprises of our endpoints, a package called as file picker, which will be useful for choosing files, and a package HTTP for calling network requests. Our client app only has 3 files: client.dart, file picker, and main.dart. The class API client basically comprises of a required parameter of base URL and an optional parameter of client, and if this is not passed, we create HTTP client. We have a function recognize test, which internally calls the respective endpoint. It calls in the survey and finally gets a response in the form of string. There is another function recognize celebrity which takes in the parameter uint8list. This calls the respective endpoint. Next, it encodes the image bytes into form of a string using the base64 encode. Next, using our client, we call a post request, sending in the body in the form of image parameter, and the image data is of type string. The response from the endpoint is in the form of a map of string dynamic which is converted into a celebrity model response, and this model comes from the package Rekognition. This is the UI of our client, and once we click on pick file, it calls the function pick file, and inside this it performs the call to file picker, which is the package we installed. Once we have the path of the file which we selected, we get the bytes of that file using the path.bytes, and this is form of uint8list. Next, we pass in these image bytes to the API client recognize if celebrity. The response from the API is in the form of list of celebrity model, and the results are shown back to the UI. For deploying our backend into Cloud Run, we first need a free account, a GCP project, and a billing account connected to the GCP project. We would also utilize the gcloud CLI for deployment. Heading back to the source code, we would run this command which helps us in creating a production build of our program. We can now see a build folder and also the steps by which we need to run this server first locally. Let's run the production version of our build by using the command here. The server is running on port 8080, and now let's try to curl. We get a response back from the server, and on the left hand side we can see the server has logged the request, and on the right hand side have the same data: ID, confidence, URLs, and name. There are 2 services which would be used for the deployment. So the first one is the Cloud Run. The second one is the container registry. Using the Cloud Run, you would be able to see your endpoint. This is the command which we would use for deploying onto Cloud Run. The name of the service, Celebrity Rekognition. Source as build, that means take a build folder. Project, which is the name of the project in the Google Cloud Platform. Finally, the region in which you are deploying, and the flag unauthenticated, which means that there is no authentication required for our endpoints. Let's run this command now, and it asks us a target platform. We will choose one. After few minutes, we can see that our service Celebrity Rekognition is deployed and is serving at this endpoint. In the container registry, if we refresh, we should see now our Cloud Run deployment. We see that inside this, we have our Celebrity Rekognition. In the Cloud Run, if we refresh this, we should see our new endpoint, Celebrity Rekognition. Heading back to the source code, if we try to curl the latest URL, we should see the response returned. Inside the Cloud Run logs of Celebrity Rekognition server, we should see see the requests logged. Inside the Cloud Run service of Celebrity Recognition, we see the log which states that, hey, our requests have been captured. In our client-side code, we change the base URL from localhost to the Cloud Run one. Let's run the macOS app again now. We run the app again, pick file. This one should hit our Cloud Run endpoint, and we see the celebrity is Cristiano with a matching percentage of 98. Back in the Cloud Run logs, we see our new endpoint recognize if celebrity is logged also. As we have two endpoints, we write the test cases for both of these. We make use of a package mocktail with the help of which we mock a request context, request, URI, and also our image recognition repo. Inside the main method, we create the instances and also a sample model response. Inside our setup all, which is a function to be run before all the tests, we register the fallback value of this created sample model. Inside the setup function, which runs before each test, we initialize the instances and also mock our data source. We also mock the incoming requests and URIs. In the first group of tests, we check if the response of all the tests below are a 4 or 5, as we only allow the method type get. The test for if the method is delete, head, options, batch, put all should return with method not allowed. The second group of tests check whether the response returned is an empty or if the response returned is a celebrity model. In the first test, we create an empty response and return it back once the function is hit. We return back the method of type HTTP get. In the expect statement, we check if the status code is equal to HTTP status OK, and also the JSON response from the service, is it empty or not. This completion is basically for testing the value returned from a future. In the second test, we return a celebrity map, which is our model response when the function is invoked. The method is returned as an HTTP get. In the expect statements, we compare the status code with HTTP OK, and in the second case, we expect the response is of a type JSON and the future completes with the model. For our second endpoint, we also mock the request context and also the repository. We create the instances and a sample model response. In the setup, we instantiate the instances and also mock our data source. We have two group of tests, the first one for 405 and the second one for testing the endpoint. Inside the 405, we check all the methods like delete, head, options, etc. return with the 405. In the second test, we check for the method and return post. We return a model response when the method is invoked. In the expect section, we see if the status code is HTTP OK and the response is of type JSON, which matches with the sample model response. Let's run the test cases now. We see all the tests are passed, and let's try for the other endpoint. We see that the test of the other file is also passed.